So now let's take an equation like this: 2 bracket x plus 7 bracket close is less than minus 4. So what you are going to do is firstly open the bracket, so this becomes 2x plus 14 less than minus 4. Now what you are going to do is subtract minus 14 on both sides. So it becomes 2x less than minus 18, and then what you are going to do is divide both sides by 2. So what you get is x is less than minus 9. Now let's take another equation: 11 minus 2x greater than equal to 5. Now what you're going to do is subtract 11 on both sides. So what you get is minus 2x is greater than equal to minus 6. So now as you can see, the coefficient of x is negative. So always remember, first what you are going to do is multiply both sides by minus 1. As you can see here, I have multiplied both sides by minus 1, but in case you didn't notice, I have also switched the sign. Don't forget to switch the sign whenever you multiply anything by negative. Alright, now what you are going to do is divide both sides by 2. So 3 is greater than equal to x. Always remember the thing I just told you. When multiplying or dividing by a negative number, always flip the sign. Alright, now let's move on to the 3 types of root. So I've taken this picture from the Cambridge maths book. As you can see here, these are the 3 types of root. 2 distinct real roots where the answer of x is completely different to one another. 2 equal root where the answer of x is same whether I use plus or minus. All of this is depending on the plus, minus, square root 36. Remember this, or square root, whatever is inside the square root. And as you can see here, negative numbers will not have a square root. This will not give any real solutions, so no real roots. So now we are going to discuss the discriminant. This will help you in understanding the roots more. Now let's see. So b square minus 4ac is the discriminant. This will help us decide how many solutions of an equation are there. Now let's take a look at the quadratic formula. Remember, do not memorize this. This will be given to you. X equal to minus b plus minus square root b square minus 4ac over 2a. Now you can see that the number of solutions will completely depend on b square minus 4ac. As you saw before, if it was negative, there will be no real solutions. Just like that, I am going to use the same logic over here. So if b square minus 4ac, this part was square root 0, then only minus b over 2a will be left. So this will only give you one answer of x. Now remember, if b square minus 4ac is less than 0, which means it is a negative number, so square root of negative number will not exist, hence no real solutions. So remember this, and then when you check it is greater than 0, for example any positive number, let's take 4. So now as you can see, it is plus and minus outside, so when you open this, it will give you plus minus 2. So you will get two answers of x, once with plus 2 and once with minus 2. So there will be 3 general rules. I'm going to show you in the next slide. Alright, now let's see. I've also taken this picture from the Cambridge book. As you can see over here, when your b square minus 4ac is greater than 0, you will have 2 distinct real roots, just like we discussed before. You can see this is due to this. This means that the coefficient of x square a is greater than 0. Remember, 0 was over here. As you can see, the second one is equal to 0. It gives you 2 equal roots, or basically one answer that will be equal for both, and then there is less than 0, which gives you no real root. As you can see, it is not intersecting with the curve. So anyways, now let's move on to an example question from Cambridge. As you can see here, we have a question: find the values of k for which the equation 4x squared plus kx plus 1 equal to 0 has two equal roots. So for this question, firstly remember what had two equal roots. So firstly, two equal root means b square minus 4ac is equal to 0. Now all you have to do is input the coefficients like this. As you can see, the coefficient of b was k, and the coefficient of a was 4, and the coefficient of c was 1. So what I did was put k over here, k square minus 4 into a into c. So as you can see, I got two answers for this. K is equal to plus minus 4. So now let's move on to finding the coordinates of intersection for a line and a curve. So now let's take a question like this. Find the coordinates of intersection of line y is equal to x minus 2 and the curve y is equal to x squared plus 5x plus 2. Remember how we did the simultaneous equation? Now we are going to use that same concept over here. Now let's presume both of the y's have a same value. For example, we can take any y is equal to 0, y is equal to 1, y is equal to 2, any value. Both of them have an equal value. This is all I'm saying. Y is equal to y basically. So what I'm going to do is put both of the equations x minus 2 and x squared plus 5x plus 2, both of them equal to one another like this. X minus 2 x squared plus 5x plus 2, and then what I did was move both of these to one side. As you can see over here, 0 is equal to x squared plus 4x plus 4, and then I used my calculator to get the answer of x. If you don't want to use calculator and they gave you for working, remember how I taught you the factorization method like this. 4, remember 4 has 2 into 2, and 2 plus 2 is also equal to 4. So you have two numbers which are 2. So x squared plus 2x plus 2x plus 4 is equal to 0. So now let's factorize this. So x into x plus 2 plus 2 into x plus 2 equal to 0. Let me bring it down. So what I have is x plus 2 is equal to 0, which means I have x plus 2 to the power of 2 is equal to 0. If I took square root on both sides, what I have is x plus 2 is equal to 0, and then x is equal to minus 2. This is how you can use the factorization method to do this. And then what you can do is, as you can see, y is equal to x minus 2, then you can do y is equal to minus 2 minus 2. This becomes y is equal to minus 4. You can always confirm the answers by putting it into both equations and checking whether they have same coordinates at that point or not. For example, as you saw here, I put in the coordinate x is equal to minus 2 into the line y is equal to x minus 2. Now you can also put this into curve and make sure they have the same coordinates. For example, the curve has the equation y is equal to x square plus 5x plus 2. So when you put minus 2 into this becomes 4. 5 into minus 2 becomes minus 10 plus 2. So as you can see, this becomes minus 6 plus 2 minus 4. Hence they have the same coordinate. This proves that our answer was right. So now let's move on to intersection of line and a curve. So now let's take a question from Cambridge again. Find the value of k for which y is equal to x plus k is a tangent to the curve y is equal to x squared plus 5x plus 2. So remember what we did earlier. We presumed that y is equal to y. They have one same coordinate. So we are going to do that again. Y is equal to y. So we can keep both of these equal to one another like this. X plus k is equal to x squared plus 5x plus 2. Remember that it says tangent to the curve. So I'm going to show you the picture of what it means. As you can see here, the curve touches the x-axis at one point, and as you can see what is happening. So now you can presume from this that b square minus 4ac is equal to 0. So using that, we are now going to solve the question. So as you can see here, b square minus 4ac is equal to 0, and then I kept them both equal to one another, and then you can move both of them to one side. This becomes a quadratic equation, as you can see here. Then you have the coefficients of a, b and c. Now you put them into the formula b square minus 4ac is equal to 0, and you get the value of k. Well, this is the end. So good luck for your future. Don't forget to subscribe and like this video for future content. I'm going to upload more examples and more questions so you can further learn more. Alright.